Good morning. Once again, I welcome you to this lecture on foundation engineering, and in the last lecture, I was actually discussing about the capacity of the pile and then single pile, and then also I have discussed about the use of group pile, use of piles in group, and there also I have mentioned that when the pile will be used in a group, then actually the capacity generally will be reduced. Not suppose if n number of piles are there, then your final capacity will not be n times the individual capacity. Sometimes it may be, but in many situations it will be reduced. And what are the situation, it can be full, will be the n times the individual capacity, where it will not, all those things I have discussed. And then when the pile is used in a group, then because of the interaction between the pile, they are actually efficiency is reducing. So, that how to calculate that efficiency, that also I have discussed. And then finally design of capacity of the group, two different ways can be done. One is actually, suppose I will calculate the individual pile capacity, and based on their spacing and diameter I can find out the efficiency. And then if I assume that the piles are independently failed, if at all fail, then independently pile will fail. In that case, I will calculate the capacity of group efficiency multiplied by the individual capacity multiplied by the number of piles. So, that is one way of obtaining group capacity based on individual pile failure. But in, as I have mentioned in the previous lecture, that if the piles are closely spaced, then instead of pile failing individually, they may fail as a whole in the form of a block. And that block, actually what will be the dimension of block, and then how to using that block, how to find out the capacity of the group, that block capacity of the group, that perhaps I have not discussed. So, that part I will take, and then finally, I will take a numerical problem, and then a pile group with based on individual pile failure, what could be the capacity, based on block failure, what could be the capacity, and finally, what could be the recommended value of design value of the pile capacity, that I will discuss. So, first let me take the first slide, that is actually giving you the how I can consider the group. As you can see here, suppose the 4 piles are a group, it can be any number. Suppose if there is a 9 numbers of piles are there, suppose like this. This is also another group. So, suppose something like that pile cap will be there, and if I draw the elevations, we will be something like this, you will see something like this, and we will see something like this. So, whatever may be, so whether it is 4 or 6 or 8, anything. So, there may be square or rectangular pattern if it is placed. So, this is actually in a square pattern, 4 piles are there, pile number 1, suppose this is 1, this is suppose 2, this is suppose 3, and this is sub 4. So, this is actually 2 and 3, and this is showing 1 and 4. Okay. Now, I have to calculate the block capacity of the pile, and to find out the block capacity of the pile, I have to find out the dimension of the block. So, how to find out the dimension of the block? You can see that if the piles are, you can see here the outer, this is the diameter d, and this is the spacing actually from here to here, it is the spacing center to center, and this side actually it will be how much? It will be d by 2, and this side will be again, this side it will be again d by 2. So, ultimately if I draw a line tangential to the external surface of the pile, and then whatever, if it is a square pattern or rectangular pattern, then either you will get a square or rectangle. Suppose I will do this once again, draw here separately, suppose like this and like this and like this. So, I will draw the tangent from here I will draw the tangent from here, I will draw the tangent from here, I will draw the tangent from here. So, that way this is the block I am getting the dimension of the block or top dimension I am getting. So, what should be the dimension? So, if it is the center to center distance is S and then it will be d by 2 and here also d by 2. So, this total distance W will be equal to S plus d by 2. So, d by 2 multiplied by 2, that means S plus d. Okay. So, suppose here actually you can see here there are S S. So, that means here dimension W will be equal to twice S plus d by 2 multiplied by 2 twice S plus d. So, that means if in a particular row if there are 3 or 4 or whatever may be the numbers, how many in between spacing is there, you can see 1 or 2. So, twice the spacing multiplied plus d will be the width. So, here actually similarly I have shown that how we have got W we have got shown here, because if tangentially if I draw the line that give you the W and L. Now, how to find out W and L, that is the way it is shown, that when here actually W, if this is W, if this is W, if width W is this, then actually you can see S plus d by 2 plus d by 2. So, that is why I have written twice S plus d by 2 multiplied by 2. So, twice S plus d ultimately. Similarly, this direction also will have same thing, this direction also will have same thing if there is equal space in that direction also. So, there also it will be twice S plus d, and here actually since single spacing only 2 piles are there. So, only one S. So, S, so that is S plus d by 2 multiplied by 2. So, S plus d, this side also same thing, if the spacing is same L also will be equal to S plus d by 2 multiplied by 2, that means S plus d. And this is actually dimension plan view of the block. And what is the elevation? That is elevation actually embedded length of the pile will be your length of the block. So, that means we are getting the block dimension equal to W, L and D. And so, then when you get a block and then if you can find out what is the base resistance, what is the frictional resistance, and based on that I can find out the capacity. So, let me go to that part next. You can hear that it is written here, for pile spacing less than 3 times the pile diameter in clay, group capacity may be considered as a block capacity. See, individual pile, that means whatever I have done, that is Q group equal to efficiency multiplied by Q I multiplied by N, that is the way, that is individual pile failure, then all the piles are independent. Now, when the piles are closed, that means less than 3 times the diameter, then it may also flip, there is a chance of failing as a block. So, you have to find out the block capacity and compare with this and see which one is smaller. So, that is what may be considered as a block capacity, and total capacity can be estimated by treating the group as a pier. As I have told, what is the dimension of the pier? Dimension of the pier is actually W, L and D. And what is W, L and D that I have shown? For pile spacing less than 3 times the pile diameter, the group capacity can be obtained applying the following equation. So, here you can see here we know that this is actually Q I or Q S. So, Q S actually what? F multiplied by A S. So, A S actually nothing but A S is nothing but a perimeter is twice W plus L and multiplied by L or D here. So, this becomes the perimeter. So, that is what it is 2D W plus L multiplied by F. This is actually nothing but that is nothing but F into A S, and since it is a square. So, it is bearing capacity equation you can recollect that 1.3 CNC and this is nothing but AT, that means base area. So, 1.3 CNC is that is QT multiplied by AT. So, the 1.3 CNC is the QT and AT is the W multiplied by L. So, this is the way actually one can find out the block capacity. And whatever terms I have used, these are explained here. D is the depth of the pile, W is the width of the pile, L is the length of the width of the pile group, and L is the length of the pile group. F is the unit adhesion developed between cohesive soil and the pile surface, and which will be equal to alpha times C. Same principle whatever we have used for capacity calculation for single pile. Same thing when it is a block also, it should be alpha times C, and C is the cohesion or undrained shear strength of the soil. N C is the bearing capacity factor for a shallow rectangular footing, and which is actually while calculating the capacity of the single pile, we have mentioned that since the deep foundation C N C will be increased, and that N C in regular shallow foundation we have seen that is 5.14, but for single pile we have used that as a 9. But when the piles in a group, at that time when you are considering as a block, and that block dimension is quite big, and because of that with respect to depth actually we can consider shallow foundation if you are not increasing the this value. So, here actually when you calculate the block capacity, that time your N C value will be 5.14 as it was used in the shallow foundation. When the pile assumed as a block, that time when you want to calculate the capacity, then N C value to be taken as 5.14, whereas if you want to find out the capacity of the single pile, that time N C to be taken as 9. So, this difference can be should be remembered. Now, we can see here as I have told you that you have to in the design finally what happen, you will be getting number of piles in a group, and then suppose their spacing everything is known, you can find out the individual capacity and you can find out the group capacity. So, now two group capacity calculation we have got now in the two ways we can find out. One way is actually efficiency calculation, then multiplied by individual pile capacity multiplied by number of piles, that is one that is actually based on individual pile failure, and then another way actually to consider as a block, and that is actually block capacity. So, group capacity can be either individual that means Q G, you can say Q G based on individual pile failure and Q G based on block failure. These two ways can be estimated. So, here actually there is a pile group, and you can see the B and W is shown. So, from here Q design and group will be efficiency times I1 to n Q A I. So, Q A I means actually what? You will get Q ultimate I and Q allowable I. That means what is the difference in this? That means you have to divide by factor of safety, then I will get this one. And how to find out QAI? QAI will you have to find out individual pile skin friction, individual pile tip resistance, then apply factor of safety, then based on that you will get QAI. So, that is actually design value of group based on individual pile failure, individual pile failure. So, this is one group we will get. Next, and for the and you can see and then we have shown also group capacity, that is another I have shown, and group capacity Q block, you have to suppose if there is a this is the block we have considered, pile cap may be somewhere here, but the block, this is the block we have considered. So, Q block you will, so that means I have now this is the one based on individual pile failure, this is based on block failure. So, I will calculate both and finally, I will compare and the smaller one to be recommended. So, that minimum of, so Q design group will be equal to this based on individual failure what is the group capacity, and based on block capacity what is the group capacity, based on block failure what is the group capacity. So, these two to be calculated and then compared to find out the design value. So, based on these, now I will take a problem. Now, suppose the problem is given like this: a pile group consists of 9 friction piles in clay soil. The diameter of each pile is 0.4 meter and the embedded length is 9 meter, and center to center pile spacing is 1.2 meter. Soil conditions are shown, actually I will show the figure, and determine the block capacity of the pile group using a factor of safety of 3, and allowable group capacity block capacity using factor of safety 3, allowable group capacity based on individual pile failure use a factor of safety 2 along with the converse lever equation for pile group efficiency. That means, whatever equation I have shown, that efficiency equal to 1 minus theta multiplied by m into n minus 1 plus n into m minus 1 divided by 19 mn, that is by the name of Converse-Leverett, that equation is named. So, that means, while calculating allowable group capacity based on individual pile failure, that time you have to single pile, you have to take a factor safety of 2, and efficiency to be calculated. There are different methods I have already mentioned. So, you have to use particular method, that is Converse-Leverett method, that means, this is the equation. And so, block capacity we will find out based on group capacity based on individual failure also we will have to find out. And then final third one, actually design capacity of the pile group, we have to find out the design capacity. How to find out the design capacity? I have already explained that you have to compare the two values, the smaller one or lower one to be taken as a recommended design value for the group capacity. Okay. So, with this, so I have in this problem, actually it is mentioned that soil condition shown in the figure. So, let me go to the figure. You can see the figure, actually here the 9 piles are shown here, and this is actually so 1.2 meter 1.2 meter spacing both side, and the depth is 9 meter, actually you can see, and this is the ground mark. Okay. And so, this is the problem, and clay soil. So, unconfined compression strength is Q u is given 100 and kilonewton per meter square. So, from here I will get C equal to Q u by 2, that means 100 by 2, that means 50. Okay. And gamma may not be used in the calculation, but it is given as a routine soil information. Here actually one thing is not given, that is actually adhesion factor. So, when adhesion factor is not given, it is your choice. Sometimes you can assume as alpha equal to 1, or you can take any value between 1 to 0.7 to 1, between any value can be assumed. Okay. So, these are the things. So, now based on this information we can try to see the problem, solution of the problem. So, first thing is asked actually group capacity, block capacity of the pile. So, let me go to the next page. So, let me block capacity. So, it is like this. Okay. So, this is actually 1.2, this is 1.2. So, that means this dimension, suppose this will be 1.2 plus 1.2 plus d by 2, that means 0.4 by 2 multiplied by 2. So, that means it will be 2.4 plus 0.4. So, it will be 2.8. Similarly, this side it will be 1.2, 1.2, and this side d by 2, this side d by 2. So, it will be again 2.8. So, dimension of the block is 2.8 by 2.8. So, I can find out Q ultimate no, not Q ultimate, I will find out suppose QS will be F time AS. So, F actually alpha C and C I have got 50 and alpha if I take as 1. So, it will be actually 50 multiplied AS will be how much? Since it is square 4 times 2.8 is the perimeter multiplied by length actually 9. Okay. So, this value will be there actually this value if you calculate you will get 5040 and QT will be equal to 1.3 CNC multiplied by AT. So, it will be 1.3 multiplied by 50 multiplied by 5.14 and multiplied by AT is actually 2.8 multiplied by 2.8. So, this will give you a value equal to 2619. So, Q ultimate block will be equal to this plus this equal to that means 7659. So, Q block allowable will be equal to 7659 divided by factor of safety equal to 3. So, if I do that then you will get 2553 kilonewton per 2.53 kilonewton. So, that means block capacity become this. Now, if you want to find out, this is the first question asked, second question asked actually based on individual pile failure. Okay. So, based on individual pile failure again Q I will be equal to Q S plus Q T and Q S will be equal to your 50 that is C multiplied by A S will be equal to how much pi multiplied by 0.4 multiplied by 9. So, this is actually your so this will be coming 565.5 and your Q T will be equal to it will be CNC 80. So, C is 50, NC actually individual pile. So, it will be 9 and 80 equal to pi multiplied by 0.4 square divided by 4 and that if you calculate it comes around 56.5. So, your Q ultimate individual it comes these two together around 622 kilonewton and Q allowable I that will be 622 divided by 2 that means 311 kilonewton. Now, your Q group based on individual failure it will be eta multiplied by Q I allowable multiplied by n. So, this is already known, this is known 9 and eta to be calculated. If I put the eta value you can say your tan theta it will be theta you will be equal to tan inverse d by s. Okay. If I do that then you will get a theta equal to 18.43 degrees and then if you put that equation eta equal to 1 minus theta multiplied by 3 multiplied by 2 plus 3 multiplied by 2 divided by 90 multiplied by 3 into multiplied by 3. So, if you calculate it comes around 0.73. So, if I put this 73 value here and then Q I value then you will get a capacity equal to 2043 kilonewton. Okay. So, this is actually that means second problem part second from first I am getting the value actually equal to 2553 and from second I am getting the value equal to 2043. Okay. So, these two values I have got, this is based on block failure, this is based on individual pile failure. So, two values I have got. Now, I have to recommend for the design. So, what value I should recommend? As I have mentioned that minimum of these two. So, minimum of this, so this is the minimum, that means based on individual pile failure, whatever capacity I will get, that could be recommended value. So, Q design ultimately you can recommend Q design will be equal to 2043. So, approximately you can say 2050 also can be 2050 or 2000 itself can be given, 2000 kilonewton will be the capacity of this group. So, this is the problem actually for calculation of group capacity of the pile when they are n number of piles in a group and particularly in the square group. Most of the time it will be square group, it may not be of course, in that case you have to do differently, but when it is in square group, then how to find out the block capacity, how to find out the group capacity based on individual failure, these two to be checked and based on that whatever the lower value to be recommended as the group capacity of the design of the pile group. So, this is the another application actually, that means I have discussed about the pile capacity, single pile driven in clay, driven in sand, and then group capacity again pile failure individually or as a block failure. So, two different ways. So, these are the things are there, and of course, this type of problem whatever I have taken, it is generally when it is in the clay, but when it is in the sand, the efficiency generally will be taken as 100. So, it will be that there is no issue to find out the group capacity. Okay. So, with this I can stop this. Thank you.